I'm pretty sure that no matter what you do in your life, at some point you've seen one of these videos on Facebook, Instagram, YouTube, or wherever, where they make one of these tables, wooden tables, where they pour the resin onto the table, and in the end it just looks amazing. Surprise, they actually use epoxy resins for that. But what are epoxy resins, and can you only use them to make furniture? In general, the properties of epoxy resins are a very high hardness, good durability, high ductility, very good chemical resistance, and extremely good adhesion to metals. Or in other words, without epoxy, our world would look something like this. They're used, for example, in factory floors because of their high chemical resistance. So if the oil drops or whatever they use in the factory, if you spill that on the floor, the epoxy can handle that. Then, of course, they are used for corrosion protection, but also as primers in commercial aircrafts because of their low flammability and also because they don't form toxic smoke. That means in case of an emergency, there's actually enough time for the people to get out of the plane. However, besides that, you will not see an epoxy coating, for example, as a top coat on a car. And the reason for that is, besides their extremely good chemical resistance, corrosion protection properties, the one thing that they cannot handle is UV light. If epoxies are exposed to UV light, then they start yellowing, and that's something you don't want to have on your car. But before we take a look on what epoxies are on a chemical basis, I want to address some health issues. And the health issues that are involved with using epoxies, they are really no joke. So I can't emphasize that enough. Whenever you work with epoxy, make sure that you understand the risks. Every epoxy resin comes with a safety data sheet. And if you don't get a safety data sheet, then ask for it. It's so important. Look at the safety data sheet, what it says about safety equipment. Working with epoxies can lead to sensitization, and that means that you get allergic to epoxies. And that can happen no matter if it's the first time that you work with it or the 100th time that you work with it. It just can happen at any time. And the risks increase the more you're exposed to it. Also, they can lead to occupational asthma, which means that whenever you're exposed to epoxy again, that you develop asthma. So in a nutshell, it's very important that whenever you do anything with epoxies, if that is at home for a personal project or at work, make sure that you have the safety equipment, and generally that involves wearing gloves and also a respiratory mask. But now back to the chemistry part. Let us draw the chemical structure of an epoxy molecule with the repeating unit here. This structure is comprised of alternating bisphenol A and epichlorohydrin molecules, and the only reason why we call it epoxy resin is because of the two functional groups here and here. But for a better understanding, let's look at an actual example. Most of the epoxy coatings, they are actually two component systems consisting of a base component and a hardener. And those two components are mixed only right before the application. The base component consists of the actual epoxy resin, then solvents, dispersing aids, and pigments and fillers. And the hardener consists of, for example, an polyamide resin and only solvents. In terms of solvents, it is important to have a certain amount of true solvents such as methoxypropanol, methoxypropyl acetate, or methyl isobutylketone, but also to have some amount of alcohols, for example butanol, to ensure the compatibility between epoxy resin and polyamide resin. In terms of hardener, we chose a polyamide resin for that, and the chemical structure looks something like this for a polyamide resin. And in fact, we could have chosen something differently, and we'll look at different hardeners later in the video. The only important thing is that we have these functional groups here and here that can react with the epoxy groups. But now let's take a look on what happens after application, after we mix the base component and the hardener, and after we applied our coating on our desired substrate. Directly after application, we still have the solvents, we have the pigments and fillers, and of course we have the epoxy resin and the polyamide resin still in the film. First of all, these solvents, they evaporate. Depending on the solvents that are used, that's faster or slower. The pigments and fillers, they don't do anything, they just stay in the film. And the epoxy and polyamide resins, they react with each other to form a very strong network. And this reaction and the strong network formation is the reason for example, the high ductility of epoxy coatings and also the good chemical resistance of epoxy coatings. But what is the chemical reaction that occurs between epoxy and polyamide? We already know the chemical structure of epoxy. We also know the chemical structure of polyamide. And the epoxy has the functional groups here and here. And the polyamide has the functional groups here, 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 and here. Very important, this group and this group, they take not part in the reaction. Those are part of the polyamide group. They don't react. And because only the functional groups can take part in the reaction, we can simplify all that a little bit to make it easier to understand. And we do that by just writing R and then only take into account the functional group. And the reaction between epoxy and amine group is a polyaddition reaction, so that means there are no byproducts released from this reaction. And what happens is that for the reaction we have this bond going here, this bond opening, and then we get the cured molecule that looks like this. And then potentially we have another H atom here. So that means we could have another epoxy resin here reacting again. And if you look at how many H groups, how many functional groups this polyamide curing agent actually has, there's a lot of potential for a lot of reactions. So what we get is something like this. A very strong network. And now there's of course a lot of potential to fine-tune the properties of these epoxies. And one way to do it is by using different curing agents. In our example above we had the polyamide curing agent. And as you can see, it is a very large molecule. It has a high molecular mass, and that means that the reaction rate is also slow. In addition to that, we have this fatty acid molecule. And this part here is very hydrophobic, which is why such curing agents are often used for corrosion protection applications. But we can also use aliphatic amines or cycloaliphatic amines. In these examples, we have the functional groups here, 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 and here. And you can also see that compared to the polyamide curing agent, which is a very large molecule, these aliphatic amines, or the cycloaliphatic amines, they are much smaller, which means they react much faster. Additionally, these smaller molecule structure, they also make the end product, the network, more rigid. And if you look at this ring structure here, you might imagine that this one looks even more rigid than, for example, this aliphatic amine structure. So there is a lot of potential to fine-tune your properties with different curing agents. The last type of curing agents that are used and that I want to mention are polyamine adducts, which is basically a reaction that we already saw. It's the curing reaction between the epoxy and the hardener, but this time we add the curing agent in excess. And that will result in a structure that looks somewhat like this. And as you can see, again, we have the functional groups here and here. So if you now add an epoxy resin, then it can react with these functional groups here. And again, the molecular weight of those polyamine adducts is higher, and thus the reactivity is also lower. And of course, you can also fine-tune your properties by playing with different epoxy resins. You can choose different molecular weights that will influence the ductility, flexibility of your product. And then there are the pigments, additives, and fillers that you can play around with, but that's probably a topic for another video, so I don't want to get into details right now. But yeah, that's it. Now, with that knowledge, you can fine-tune your own epoxy resins for your own applications, for your own needs. And please remember also the safety issues that are very, very important. Thanks for watching this video, and I see you in the next video. Bye.